What if traveling to space didn't require giant rockets or tons of fuel? Imagine simply riding an elevator straight from Earth's surface up into orbit. Sounds like science fiction, right? But the idea of a space elevator is becoming more than just a dream. Could this revolutionary technology soon change how we reach space, making it safer, cheaper, and more accessible? In this video, we'll explore how a space elevator works, the challenges it faces, and whether we could really travel without rockets very soon. So without any further delay, let's get started. What exactly is a space elevator? A space elevator is an ambitious idea that could change how humans travel beyond Earth. Instead of launching rockets, imagine a giant cable stretching from the ground up into space, with an elevator-like vehicle climbing it. This cable, or tether, would be anchored to the Earth's surface and extend all the way to a counterweight beyond geostationary orbit, about 22,000 miles above us. The centrifugal force caused by Earth's rotation would keep the tether stretched tight. The elevator climbers would move up and down this tether, carrying cargo, satellites, and even people, all without the massive fuel or explosive power rockets require. This idea was first imagined over a century ago, but it has only become more realistic with modern materials and technology. If built, the space elevator could provide a smooth, energy-efficient way to access space, potentially lowering costs and increasing the frequency of space travel. It's a futuristic concept that sounds like science fiction, but scientists and engineers are seriously working to make it a reality. Understanding this foundation is key before diving into how it would work. How would a space elevator work in practice? The space elevator relies on a very long and incredibly strong tether that connects Earth to a point in space beyond geostationary orbit. This tether needs to be made from materials stronger and lighter than anything currently available, with carbon nanotubes and graphene as the top contenders. The tether would stay stable because Earth's rotation pulls outward on the counterweight in space, balancing the pull of gravity on the Earth end. Special climbing vehicles, called climbers, would use electric motors powered by solar energy or wireless power transmission to slowly ascend the tether. Unlike rockets, these climbers wouldn't face dangerous explosions or fuel shortages. Instead, they would move steadily and safely up the cable, potentially carrying tons of cargo or passengers. Once at the top, payloads could be released into orbit or sent on to the moon and beyond. This system could drastically reduce launch costs and increase reliability, opening space access to more people and businesses. While the technology is still developing, the basic principle of a balanced tether and climbers is straightforward and promising. Why do we need a space elevator? Traveling to space today mostly depends on rockets, which are very expensive and use large amounts of fuel. Each rocket launch can cost tens to hundreds of millions of dollars, making space travel limited to governments or large corporations. Rockets also produce pollution and carry risks of failure, which can endanger lives and destroy valuable equipment. Because of these issues, space missions are rare, costly, and often carry limited cargo. A space elevator could change all of this by providing a more affordable and sustainable way to reach space. Instead of relying on powerful rocket engines, climbers would travel smoothly up a tether, powered by electricity from solar panels or wireless energy beams. This method would reduce costs dramatically, potentially making space travel thousands of times cheaper. Lower costs could open the door to new opportunities like space tourism, allowing ordinary people to experience space. It could also support scientific research by enabling frequent launches and easier transport of satellites and equipment. Furthermore, a space elevator could help humanity reach the moon, Mars, and beyond by providing a reliable supply route. Overall, space elevators could make space more accessible, safer, and environmentally friendly, opening a new chapter in human exploration. The biggest challenges facing space elevator construction. Building a space elevator is one of the most difficult engineering projects ever imagined. The biggest challenge is creating the tether, a cable that must be incredibly strong, yet light enough to stretch from Earth's surface all the way into space, about 22,000 miles high. Current materials like steel or Kevlar are nowhere near strong enough. Scientists are exploring advanced materials such as carbon nanotubes and graphene, which are millions of times stronger than steel. However, producing these materials in long, continuous lengths required for the tether is still a major hurdle. Another serious problem is space debris. The tether would pass through busy regions of orbit, where satellites and fragments from old rockets float around at thousands of miles per hour. Even a small collision could damage or sever the cable. Designers must find ways to avoid or repair damage quickly. Weather on Earth also poses risks. The tether needs to withstand storms, lightning strikes, high winds, and temperature extremes without breaking. Finally, the cost of building a space elevator is expected to be in the billions of dollars, requiring major investment and global cooperation. Despite these challenges, experts remain hopeful that ongoing research will find solutions to make space elevators possible in the future. Recent developments and current projects. Interest in the space elevator has surged in recent years, driven by advances in materials science and growing enthusiasm from both private companies and governments. One of the most notable projects is led by Japan's Obayashi Corporation, which announced plans to begin building a space elevator by 2050. They aim to use carbon nanotube technology, which offers the extraordinary strength needed for the tether, though mass production is still a major challenge. Meanwhile, the International Space Elevator Consortium, ISEC, an organization made up of engineers, scientists, and space enthusiasts from around the world, continues to research and test key components. They focus on climber design, power delivery methods like wireless energy transmission, and tether durability under harsh conditions. Universities and startups are also contributing with smaller experiments, such as testing materials in space and developing climbers that could one day ride the tether. Governments are watching closely, recognizing the potential for space elevators to transform how humans access orbit and beyond. Though a full-scale elevator doesn't exist yet, these coordinated efforts show the concept moving from imagination to tangible progress. If these projects continue to succeed, we could see prototype systems in the coming decades, bringing the dream of rocket-free space travel closer to reality. What could the future look like with space elevators? If space elevators become a reality, the future of space travel and exploration could be dramatically different from what we know today. By reducing the cost of sending cargo and people into orbit, space elevators would open space to new industries and opportunities. Space tourism could become affordable enough for many people to experience orbit firsthand. Scientists would gain easier access to space for experiments and building larger, more advanced space stations. Manufacturing in zero gravity might become commonplace, producing materials and products impossible to make on Earth. Space mining could become practical, providing rare minerals needed for electronics and energy. With easier access, colonies on the Moon and Mars could grow, supported by a steady flow of supplies sent via elevator. Space elevators might also help clean up orbit by safely removing debris. However, building and maintaining these massive structures will require international cooperation, careful planning, and new technologies. But if these hurdles are overcome, space elevators could turn space from a remote frontier into a routine destination, forever changing humanity's place in the universe. Building a space elevator is a huge challenge, but its potential to change space travel is incredible. From lowering costs to making trips safer and more frequent, it could open a whole new era of exploration. As technology advances, this dream might become reality sooner than we think. Thanks for watching, and if you enjoyed this video, please like, share, and subscribe to our channel for more content like this. Until next time, keep looking up.